It's one small step for man, one giant leap for mankind.
Nearly everyone interested in space has seen this picture. It was released by NASA and has the iconic name, the Blue Marble 2. You can find the picture everywhere, but one of the best places to find it is NASA's own website. This photograph is iconic because NASA says it is one of the most detailed true-color images of the entire Earth to date. To put it in a nutshell, the picture is iconic. Well, amazingly, it turns out a number of internet sleuths have now found compelling new evidence that the image is indeed a fake. Now, let's take a look. At first the photo seems legit. I mean, it looks like Earth, the Earth that we have always been told we live on. But as the savvy internet sleuths point out, if you take a closer look, things start to take a somewhat sinister turn. Look closely at the repeating cloud pattern. Here we can see clear examples that the photograph has not only been doctored or constructed, but also strong evidence that whoever done the doctoring used repeating photographic templates. That is, they cloned parts of the image and repeated it. That is, the photograph is a construction. This does not happen in nature. Clouds do not repeat in the same pattern like this. The chances of this happening in the same photograph are low. The only way this could happen is if someone has cloned clouds and painted them on. This of course could be for a number of reasons. You could argue that NASA simply touched up the photograph for effect, or that it was a problem with the imaging systems that were used. But still the question exists, why is NASA releasing fake pictures of Earth? If they are going to release a picture of Earth to be used in museums and by educators, as they state for the Blue Marble 2, then should they not release real images of Earth instead, or manipulated or fake images? Since the natural extension of this is, what other images have they doctored? The Moon, Pluto, Mars? Maybe all of them. And if they are faking pictures to such an extent, whether by wanting them to look better, or other reasons, then what real scientific value are they? Isn't science about finding the truth? And is that not hard to do when you are being fed inaccurate, or in this case, completely manufactured data? NASA says these images are to be used by educators, museums, and scientists. Which means, they are passing off the image as a real picture of Earth, when it is not. What do you guys think? Do you think something sinister is going on? Or is there some harmless and less exotic reason?
There are great ideas undiscovered, breakthroughs available to those who can remove one of truth's protective layers.
Then in 2002, Blue Marble 2.0. NASA's Rob Simon made this. And it had wide appeal too. For example, it ended up as the default background on the iPhone.
I didn't even know until I bought an iPhone and turned it on and kind of did a little happy dance.
Simon's job is...
It's primarily taking data and making pictures out of it.
That's what this is, a composite of data sets from several different instruments translated into a picture.
To us, the really cool thing was the data set. Up until that point, there was no realistic color map of the globe anywhere.
So the land layer here comes from
the Moderate Resolution Imaging Spectroradiometer aboard Terra.
And the tricky part here was the weather.
So we actually had to take clouds out.
They stashed the clouds for later, went onto the ocean. That came from an instrument that measures phytoplankton in the sea.
Where it was low, I colored it dark blue because they're low mostly in mid-oceans. And then where it was a little bit higher, it was like a little bit brighter green.
Then add the clouds back in.
There's a small problem with it because there's a very slight gap in between each orbit.
So some of those are painted on.
It is photoshopped, but it's has to be.
Say what?
It is photoshopped, but it's has to be.
Then
there was another layer to sort of simulate the atmosphere.
And then there's this little bright spot.
It's called the specular highlight. So it's the reflection of sunlight off of water.
Those are the pieces, but you can't just slap them all together.
It just didn't look realistic. It looks kind of flat, or the clouds are sort of too see-through. So I just hit Command Z a lot.
There's artistry to creating the world.
What I imagine it to be. Unfortunately, I'm not an astronaut. I've never been to space. But I've looked at these images over and over again, trying to sort of get the essence of it. It is photoshopped, but it's has to be. It is photoshopped, but it's has to be. It is photoshopped, but it's has to be. It is photoshopped, but it's has to be.
It's amazing to think that for the majority of human history, we had almost no understanding about the sun. We didn't know what it was made of, how it formed, or how it produced energy. We didn't know how big it was, and we didn't know how far away it was.
It is photoshopped, but it's has to be.
We orbit the sun at a distance of about 150 million kilometers. Orbit the sun at a distance of about 150 million kilometers. This number is actually an average since we follow an elliptical path. At its closest point, the Earth gets to 147 million kilometers. And at its most distant point, it's 152 million kilometers. Distances in the solar system are so vast that astronomers use this distance as a standard for measurement. And so the average distance from the Earth to the sun is called an astronomical unit. Instead of saying that Pluto is 5.87 billion kilometers away from the sun, astronomers say that it's 39 astronomical units, or AU. You might be surprised to know that the distance from the sun to the Earth was only determined within the last few hundred years. There were just too many variables. If astronomers knew how big it was, then they could figure out how far away it was, or vice versa. But both of these numbers were mysteries. Ancient astronomers, especially the Greeks, tried estimating the distance to the sun in several different ways. Measuring the length of shadows on Earth, comparing the size of the moon and its orbit to the sun. Unfortunately, their estimates were off by at least a factor of 10. The key to figuring out the distance to the sun came from observing Venus as it passed directly in front of the sun. This rare event, known as a transit of Venus, happens only twice every 108 years. Once devised, the best opportunities for taking this precise measurement came during the Venus transits of 1761 and 1769. Astronomers were dispatched to remote corners of the globe to observe the precise moment when Venus began to move in front of the sun and when it had moved completely across the surface. By comparing these measurements, astronomers could use geometry to calculate exactly how far away the sun is. Their initial calculations put the distance at 24,000 times the radius of the Earth. Not bad, considering our modern measurement of 23,455 times the radius of the Earth. Modern astronomers can use radar and laser pulses to calculate the distance to objects in the solar system. For example, they fire an intense beam of radio waves at a distant object, like Mercury, and then calculate how long it takes for the waves to bounce off the planet and return to Earth. Since the speed of light is well known, the return travel time tells you how far away the planet is. Astronomy has truly helped us find our place in the universe. It's nice to be living in a time when many of these big mysteries have been solved. I don't know about you, but I can't wait to see what's around the corner of the next discovery.
So what this really is a oversimplification of what Dragon really is. It's combining a yin and yang energy frequency together, and they both attract. They want what each other has. There's value in that exchange. So contrary to what they teach in science, so we talked already about the periodic table is really a periodic table of energy. The universe is actually magnetic and light. It's not gravitational driven. It's such a weak force compared to magnetism. Mm-hmm. So what this is I'm going to induce an electrical and magnetic field. This outer ball is the male or yang field, and this silver one inside is the yin or female field.
Fascinating.
So just like males and females like to do, they are going to go at it. So with no further ado, I'm going to now put this over in order to help adjust. And we're going to turn on a vacuum pump so that we can mimic outer space. And let's see, I think it's right here.
Now you've created a special generator for this. Is this what
Yeah.
you're doing? So you've created specific frequencies, male frequencies and female frequency?
Yep, it's both male and female at the same time.
Wow.
But again, it's not canceling out because I've created space. I've created a neutral distance that they don't cancel out. They're actually, so every system in the universe is an oppositive system. So if you, like electricity for example, if you cut the electricity on one leg, the whole thing collapses. There's no system. So you have to have that send and receive, that yin and yang happening. If they come in contact with each other, then they can neutralize and cancel out like a salt or something. But what this is going to do is there's enough design in space that keeps it separate. And so instead of a sun actually being a fusion generator, eating its own hydrogen and helium, and over time, you know, it's going to use all of its fuel, it's actually being, the sun is actually being powered by something else. There's something else that's acting on that female field, if you will, that's creating that sun. So what you're going to see in here, as there's enough, the vacuum pump is pumping out the air, then eventually you're going to start seeing a orange dot, which is the male side, and a purple dot on the female side, and they're going to start reacting together. And then a purple plasma is going to start forming around the female field. Then it's going to move inside, and magnetism, not gravity, is going to pull it all together. And that plasma, or the baby of these two, is a sun. So it's in a womb in the female, if you will. So that's what this is. If it was a engine of fusion, then you'd have a super hot core, you know, getting cooler as it moves out. But it's actually the opposite. Its atmosphere is the hottest. Its surface is so cool it's like 6,000 degrees, and then inside is so cool that you can see sunspots. You can actually look into the core, and there is so cool in temperature that that's what a sunspot is.
So you're telling me what I've learned in school was not appropriate, was not
right. It's based on a gravitational theory,
and we believe that it is a magnetism.
Right, and magnetism is 40,000 times stronger than gravity.
Absolutely. Why is this purple? If it's supposed to be the sun, why is it not yellow? Explain the difference, please.
Yeah, so that basically relates to what kind of plasma is being generated based on the element that's present there. So the sun is yellow because of the hydrogen and helium makeup, whereas this is purple-ish, and it will actually condense into kind of a orange because it's mostly oxygen and nitrogen, because I just sucked out the air we're breathing to make the
Excellent.
vacuum. Yep. So what this is really doing is a male field is sending energy to the female, and that relationship is producing this energy that's now moving into her womb, and magnetism is going to pull it together. So that's why I show this is an overly simplistic demonstration of why with the different dragons there's a male and a female, or yin and yang. And this is just a way to show that, but it's also cool to see a son be born. And so here in probably 5 or so, 10 minutes, that will get tighter and tighter and tighter, and it'll be an actual visible sphere. You'll actually see a little core, and it'll even shoot out a beagle jet of pure energy. So awesome. A quasar.
What is gravity?
You have no idea. Okay, next question.
Wow.
No, here's the difference. We can describe gravity. We can say what it does to other things. We can measure it, predict with it. But when you start asking, like, what it is, I don't know.
So did I accidentally ask a deeper question than I meant to?
Yeah, no, you were meant to ask deep questions.
Apparently I was.
In life. So to say, what is it? I think Einstein, in an Einsteinian answer, we would say gravity is the curvature of space and time. And objects will follow the curvature of space-time, and we interpret that as a force of gravity. That's probably the best answer I can give to a what is gravity question.
Okay.
Oversimplification of what Dragon really is. It's combining a yin and yang energy frequency together, and they both attract. They want what each other has. There's value in that exchange. So, contrary to what they teach in science, so we talked already about the periodic table is really a periodic table of energy. The universe is actually magnetic and light. It's not gravitational driven. It's such a weak force compared to magnetism.
Mm-hmm.
And I can also say that Einstein noted that matter tells space how to curve, space tells matter how to move.
Say that again.
Isn't that beautiful?
It is. No.
Yeah,
like
so
that. That's a t-shirt.
matter and energy will curve the fabric of space.
Okay.
And it's that curvature that tells other matter how to move in the curvature of space itself. And so Einstein juxtaposed those in a poetic phrase where he said, matter tells space how to curve, space tell... Did I get that right? Yes. Matter...
I wouldn't
Matter
know.
tells space how to curve, space tells matter how to move. It's beautiful.
That is beautiful.
This is called gravity.
It takes a certain amount of time for you to pass from here all the way over to the other side of the auditorium.
Right, that's space.
That is time going. That is time going through space.
You see, that's not what they mean at all. That shows me that you have no idea. I mean, so the guy said, one of the gentlemen said, well, there are 3 dimensions, space, length, width, right? And then you have the concept of time. So something happens within that space, you got time. That's the 4th dimension. Yeah. And I said, well, I get that. Something happens within a cube, and you have time, and then you have length and breadth and width. And I get the, what's the 5th dimension, I said.
That's a fantastic band.
A fantastic band. That was my first thing. So I said, just give me another, because he said there's 11, then he said there's 17, and then I heard lately there's 26 other spaces, dimensions, multiverses. No, wait a minute. So I said, well, just give me one other dimension. I don't care about 16 or 17 or 26. What is the 5th dimension? What is it? Give me another dimension. And the answer is, we can't conceive of that.
You know, right.
So
that doesn't mean it doesn't exist.
Well, it doesn't mean it does exist. You know, so I mean, so I said to Dr. Taku, he said, it's in the, because he's working on string theory. You know about string theory.
Yeah, and I find that incredibly confusing too.
But we're not talking about the stuff you wrap a package about, Adam. It's vibration of some kind in a string. Okay? So I said, he said, it's like music. I said, well, I understand an orchestra with vibrating instruments. I got that. What do you play? What's your instrument? What do you do? When you get up in the morning, doctor, what do you do? And he says, it's all in my head. I think. I said, well, how do you prove what you're thinking exists? Because it's all theory. He said, well, I've got this very elegant
numbers, equation,
yeah. Very E/B divided to 7 to 4. It's all in his head. How do you prove a black hole? How do you know those gravitational waves proved the collision of 2 black holes?
Somehow, eventually, they are able to observe phenomena.
No, they can't observe. It's too far away. It's too theoretical. How do we know what they're saying is true? You know what it really is? It's all science fiction.
So I guess so far for me, I like the waters, the shallow waters in the Caribbean or the atolls in southeast Pacific, or southeast Pacific, or
southeast Pacific, or southeast Pacific, or
I don't know. We're going to have to do something for you.
I want to do it. I know.
Oh, yeah, I can do that. Watch this.
I know.
Oh, yeah, I can do that.
I know.
Oh, yeah, I can do that.
I know.
Oh, yeah, I can do that. Watch this. Can everybody float around for us? That was really cool, Chris. Oh, yeah. Oh, yeah. Oh, yeah. Oh, yeah. Oh, yeah.